Hello, I'm Jesse with American Radon Mitigation. Today we're working on a very common house. It was built in 1997. It's about 3,000 square feet. It has a concrete block foundation with interior drain tile. Let's go ahead and take a look at the process of radon mitigation for this kind of home. So here we're at the sump basket. We can pull that cover off. We're gonna have to replace this because it's open. So as you can see the drain tile, we've got my light in there and you can see all those little slits in there, and that allows for water to get into the sump basket, and if they had a sump pump, it would pump it out. But we can also use these slits to draw soil gas through, so we're drawing the radon-laden air out of the house with that. So what we can do is core through the floor in a different location. We'll tie into this drain tile and we'll put a sealed cover on here. So I've made one here because I've just had a blank of Lexan. I simply trace this cover, cut it out with a saw, and then I've got a 4-inch hole that I cut here, so we'll put an access port. So what I've got left to do here is I'm gonna put the cover on, screw that down with some Tapcon screws, and then I'll silicone that to make our seal here. So here we've got one of our test holes. We've got several of them throughout this house, and these allow us to measure the extent and strength of our suction that our radon system is going to create. So we've got those drilled. We're going to plug this hose into the floor with our cork, and we'll go back to our micromanometers where we can measure our pressure. So now we're going to do a communication test. We simply have the shop vac drawn on the drain tile through the sump basket cover that we put on. You can notice that these numbers are all positive, which means the house is sucking radon in. We want to get negative numbers under the entire house. So I'll turn that shop back on. You can see these numbers start to go negative. We can improve upon our radon system by doing sealing now. The top of the block is tied into the drain tile, so we don't want to draw conditioned air down there, so we can seal that stuff up. So as you can see here, we've got an unfinished basement, which gives us a great opportunity to make a more effective and efficient radon system. And we can do that because the drain tile is tied into the block wall, which is like a honeycomb network, and the top of these blocks are unsealed. So when we turn on our radon system, or our shop vac in this case, it's gonna pull this smoke or conditioned air from the house. So we'll turn that on. You can see it instantly pull that smoke down. So if we take the time to seal all this, we can make a much more effective and efficient radon system. So again, the key to radon mitigation is getting suction or vacuum under your entire home. So any openings or cracks that we have an opportunity, we want to make sure that we seal those. So we've got them on the load-bearing walls, on the walkout walls, the top of the block, any plumbing blockouts. So what we have here is a radon sealant. It's a green low VOC product, and it won't be as bad for you and your family to breathe like a polyurethane would be. So now we've got our sealing done. We're doing that communication test again. You can see our numbers are a lot more negative. And this is something that isn't required to make your radon system work, but it is going to make it a lot more effective and efficient because it's not drawing conditioned air out of the house. It is also going to help with the backdraft situation that we may face because this house has a natural draft water heater, but we'll look at that later. So our next step is to core our 5-inch hole in the floor. We'll tie into the drain tile by cutting a hole in the top of that, and then we'll take our CFM readings after that. So we've got our suction point established. We've got our pitot tube hooked up to it here. Our shop vac is here, and we've got a valve here. And this pitot tube allows us to measure how much air we're moving. So the key to getting your levels low is to get vacuum or suction on your entire house. The only way to know if we're achieving that is to take the time to measure. So we've got our 3 test holes that we drilled earlier. They're all hooked up here. And our goal is to get 5 pascals in our furthest, weakest test hole. And we're floating right around there on this purple one. So to do that, we're moving 80 cubic feet of air per minute through this pitot tube with the shop vac. And that tells me that if we use 3-inch pipe, it's going to be too restrictive. And we're going to use 4-inch pipe to make sure that we can move enough air through this radon system. So our next step is to run this 4-inch pipe out to the garage. We've got our radon sealant where our pipe will penetrate the floor here. We'll seal it up with that. We're using Gorilla Glue, which is a low VOC glue. And when we glue these together, we want to make sure that we give them a 1/4 turn if possible. The glue will set better that way. We've got our low VOC glue so that it won't be bad for the homeowner. So we've got our U-straps. We mount those at the top of the pipe and then at the bottom, and that'll hold it secure. So now we've got our pipe running from our suction point up out into the garage. We've got it secured. We've got a manometer here, which is just a system monitor, just a visual gauge to tell you your radon system is working. You want the fluid levels to be different. If they're equal at 0, that means your fan is not working and you should call for service. Here we've got an airflow alarm. If you get one accessory, you should definitely get an alarm because you will know within 30 seconds if there's a system failure. And how that works is there's a flap inside the pipe. When there's airflow, it lifts that flap up. When there's no airflow, that flap will fall and it'll trigger this alarm and this red light will come on. Our next step is going to be to run the pipe up into the attic from out in the garage. All right, so we're in the garage here. We've got our pipe stubbed out. We are going through a fire rated wall, so we need to maintain the integrity of this wall. So how we do that is we've got this smoke sealant. So this goes in that little gap around the pipe. And then we've got a fire stop collar. So how this works is, say there's a fire in your garage, this pipe is going to melt away and we don't want flames shooting into the house. So this intumescent material is going to expand when it's heated up to 60 times and close off this opening left by the pipe. So this fire stop collar just slides over the pipe. To secure that to the wall, we do have wood behind here, so we're going to use number 8 wood screws with a 1-inch fender washer. And then up on the ceiling, we are not screwing to wood, so we're going to use toggle bolts for that. And we want to use a 1-inch fender washer on that as well. So we've got the garage portion of the system finished. We've got our vent pipe wrapped in insulation, and the reason we do that is not just to make it ugly, but we get less mold and mildew on the pipe, so you won't see that. Makes it less likely to freeze, and it's going to make it a little bit quieter. We've got our fire stop collars installed. It is secured, and normally we would just run straight up into the garage attic, but here the house cantilever's over the garage 2 feet, so that's why we got this funny jog in the pipe. Our next step is going to be to run the vent pipe in the attic. So we've got our pipe stubbed up into the garage attic here. We've got to put our smoke sealant on to finish up that fire stop collar. We're going to put our 90 on, we're going to run our pipe over to our exhaust point, and then we'll run the pipe through the roof and flash it. So we're up in the attic. We've got our pipe pitched to allow for any condensation to drain back to our suction point and the drain tile there. We've got it secured. We've got it all insulated. We've got the pipe penetrating through the roof, so we cut our hole in the roof with a hole saw. Pipe comes down through. Next, we've got fan selection. This fan is oversized. This is what most companies would put in, but the reason we're not going to use this is it's running about 60 watts right now, so it's about $1 a watt here in Minnesota. It's about $60 a year to operate this fan. The other reasons we don't want to use it is it's going to pull more conditioned air from the house, so bigger heating and cooling penalty, and then it's going to give us, it's going to be more likely to backdraft the natural draft water heater in this house. So we've already mocked up the smaller fan. This is the Festa Spirit. This one gives us just over 5 pascals in our furthest, weakest test hole. So this is the fan we're going to go with. The equivalent in the Radon fan would be the RP140 or the Fantech RN1. And the equivalent in the other fans, the Festa fan would be the Maverick, and the Fantech fan would be the RN2, which would be the equivalent to this RP145. So to wrap up in the attic, we've got to get the electrician in here to put an outlet within 6 feet of the fan. I've got to go up on the roof, I'll paint that pipe to match the shingles. I'll put a critter guard cap on that'll keep birds, squirrels, acorns out of the radon fan. We're going to go down in the basement, check our pressure fuel extension, and then we're going to do our backdraft test and then clean up. So one of the last things that we do, and we find it very important, is we check your backdraft if you have a natural draft water heater. So how we do that is we're going to turn on everything that sucks air out of the house. Bath fans, the dryer, and the hood. We're going to come down in the basement and we're going to turn the water heater on. We're going to hold our smoke and our lighter here, and we want to make sure that that smoke is drawn up the flue. In this case it was not. It spilled for several minutes, and what that means is the house is sucking too much air out. It's pulling it from the roof down this chimney, and we've got air dumping in here. So when the water heater kicks on, the exhaust gases cannot go up. They come back into the house. So it's a big carbon monoxide issue. It's very common. We see it all the time. So they're going to have to get an HVAC guy in here to correct the situation before we plug in that radon fan. So to wrap up, we've got vacuum or pressure fuel extension under the entire home. Our furthest weakest test hole is slightly over 5 pascals negative, which was our target. Our manometer is now working because the radon fan is trying to suck this red fluid up. So it's simply a visual gauge telling you your radon system's working. You want the fluid levels to be different. The final thing the customer will have to do is do the post-mitigation test 24 hours after the radon system's been up and running. I'm Jesse with American Radon. Thanks for watching.